This video investigates some of the real-world applications that involve solving equations expressed in worded forms. So let's start with a taxi driver charging $25 as a call-out fee and then $2.50 for every kilometre. How far could a passenger travel if they only have $32 for their fare? And we've seen this problem in the previous video, and there we set one of the variables, cost, in terms of dollars, capital C, and the other variable of interest or pro-numeral is D, the distance travelled in kilometres. And we found that the cost is related to the distance through this rule here. This equation gives us the relationship between the distance travelled D and the cost in dollars. So the initial call-out fee, $25, and then we add to that $2.50 for every kilometre travelled. So $2.50 times however many kilometres the passenger travels. What we want to solve is the situation for the case of the passenger who has only $32 available in their pocket to spend on a fare. How far can they go? So we're setting the cost to $32, and $32 is equal to the $25 charge plus $2.50 for every kilometre. And what we find is that we can put the right hand side over on the left here, as we used to in the previous videos. Not that it matters, we don't have to, but just for consistency with previous videos, I'll write the right hand side over here. And if we look at the unknown pro-numeral D, the first thing we did to it was multiply it by 2.5, and then the next thing we did was add 25. So when we work backwards through this equation to isolate the pro-numeral, to obtain the pro-numeral by itself, we're going to undo those operations in the reverse order. So the last thing we did to the unknown was add 25, and then the next thing we did was times 2.5. So the first thing we'll get rid of is the plus 25. And the inverse operation for adding 25 is subtracting 25. Now, with an equation, to keep it equal, to keep it equivalent, what we do to one side we must do to the other. So we're going to take 25 from both sides. So 25 minus 25 on the left here is 0, leaving us with 2.5 times D, the distance. And on the right hand side here, 32 minus 25 is 7. Then the next operation we need to undo to get this letter D by itself, we need to get rid of this times 2.5. And the inverse operation for times 2.5 is divide 2.5. So we're going to divide both sides of the equation in order to keep it equivalent. What you do to the left hand side, you must do to the right hand side. We're going to divide both sides by 2.5. Now on the left here, 2.5 divided by 2.5 is 1, cancels out, leaving us with the pro-numeral D. On the right hand side, 7 divided by 2.5, converted to a mixed number, will give us the distance equal to 2 4/5 kilometres. So this passenger can only travel 2 4/5 kilometres, 2.8 kilometres. Alright, next question. The sum of John's age and that of his sister, who is 5 years older, is 30. How old is John? Alright, well, we don't know what John's age is, but what we can do is assign to it a pro-numeral representing his age, whatever it is. So we'll let n be John's age in years. Now, this leads to the following equation, because we know that his sister is 5 years older than him. So whatever John is, n, his sister is that age plus 5. So his sister is n plus 5. And we know the sum, which is to add, is n plus 5 is equal to 30. Because the sum of John's age and that of his sister, who is 5 years older, is 30. So n, John's age, plus his sister's age, n plus 5, and sum it together, add it all together, gives us 30. Alright, so if we collect the like terms, n plus n gives us 2n, and then we have the plus 5 here left over, is equal to 30. If we look at the pro-numeral n, the first thing we did to it was multiply it by 2, we have 2n. Next thing we did was add 5, and that gave us 30. So when we solve this equation, we're going to go backwards in the reverse order. We're going to undo first the plus 5, and then we'll undo the times 2. Now the inverse operation for plus 5 is minus 5. And to keep this equation equivalent, what we do to one side, we must do to the other. So if we take minus 5 away on the left, we must also take it away on the right. 2n plus 5 minus 5. Plus 5 and minus 5 cancel out, leaving 0, and we're left with just 2n. On the right, 30 minus 5 is 25. Next, so we're left with 2 times n equals 25. We need to get rid of this times 2. The inverse operation for times 2 is divide 2. And what we do to one side of the equation, we must do to the other. So 2n divided by 2, well, that 2 and that 2 cancel because 2 divided by 2 is 1. We're left with 1n. 25 over 2 gives us 12.5. So John's age is 12.5 years. He is 12.5 years old. Alright, now in the link below this video, in the description section, there's a link to a worksheet. And below that there's another link which is for containing the answers to this worksheet.